Okay, so this is question 7 of the prelim. Right, so paper 1, question 7. The first part is actually 3 marks, so it's generally well done. Most of you all were able to get the marks quite easily. So it's basically a question that involves integrating or exponential function as well as a trigo, and you also need to do integration by parts twice. Okay, so these 3 marks, right? What I need to do is you need to right. The next part would be to use a differentiation to find the exact coordinates of any turning point and determine the nature of the turning point. Okay, so you know that you see now you have a parametric equation, so you have x and y. You need to do differentiation to need to find turning point. So basically to find dy dx, all right, so you actually do need to conduct differentiation, parametric differentiation, to find dy dt and then followed by dx dt. Okay, so if you have found dy dt dx dt and you did some sort of operation on to find dy dx, I did give you 1 mark for this one. Okay, do the equation. Okay, so if you have e, okay, e cos x 2x. Okay, this is just what we do is a simple, we identify as this is to be the one. So LIET, if your teacher has told you LIT, you can also use LIT. So basically, in this case, it doesn't really matter. You can choose either one. So most of you just done, you choose either one. Some chose cosine 2x to differentiate. Some chose e2x, ex to differentiate. So in my case, I'm just going to choose ex because I'm going to choose this to be the du dx and this one to be the v. Alright, so you know this is just basically equals to uv minus integral of u dv dx. This is based on the formula. So if you have gone through a question, you're able to do an integration by parts, at least you should get 1 or 2 marks out of this. Maybe you will lose 1 mark due to careless mistake lah. Okay, can okay, so with that ex cos 2x. Okay, so the first one, if I integrate ex, I'll just get ex, right? Then cosine 2x, cos 2x, okay, plus now I differentiate 2 cos 2x, I'm going to get negative, so I'm going to get like a minus integral of like negative 2 sine 2x, right? Correct? Dx. Then maintaining my u if I integrate it, it just be e power x times negative 2 sine 2x. Okay, so this negative and this negative, correct, will cancel each other out, become a positive, and I can bring the 2 outside. So tidy up my function. I have ex cos 2x plus 2 integral of e power x sine 2x. Alright, and with this you can see that no chances are you probably, this is like a cyclic, you need to integrate it 1 more time and then you probably group all the marks one. So if you do this correctly, you should just get 1 mark here already. Well, if you've done integration by parts twice. Okay, this is the second round. Let's do another second round of integration. Alright, so I'm going to do integration to this portion again. I'm going to put 2. I'm going to integrate 1 more time. I'll put ex, right, sine 2x. So I've integrated this ex to get me ex and minus the 2 integral of ex. Okay, so integral of sine 2x, differential sine 2x is going to give me 2 cos 2x, right? So it's going to be 2 cos 2x. So I have a cos 2x. I'm going to put the cos 2x inside. I'm going to put another 2 to make it 4 outside. Okay, this is the part where some of you actually miss out the 2. Okay, so because some of you actually miss out 2. In the event, you actually put this as a 2. You left it as a 2. Okay, so it's because so due to this, you all actually did lose some marks. Okay, let me just put this properly. Okay, you all did lose some marks. Okay, so you all have to be careful because of the parentheses. Some of you did lose some mark because of the not putting the bracket properly. Okay, so also because if you put this as 2, your answer will turn out different. Like instead of a 5/5, you put it as a 3. Okay, so you just end up with e equals to ex cos 2x plus 2 ex sin 2x, right, minus, okay, 4, this is ex cosine 2x dx. And this is when you realize that basically this is nothing but the question. Alright, this all along here has been the question, right? So I'm also going to bring the 4 over to the left hand side. I'll have 5 integral of ex cos 2x dx equals to ex cosine 2x plus 2ex sine 2x. Alright, and if I bring the 5 over, take away the 5, I'll just have 1 over 5 on my right hand side and plus c, where c is arbitrary constant. So if you, again, a couple of you actually didn't put the c lah. So if you didn't put the c, I mean in the past we used to minus 1 mark, but this time around I just put it as a presentation error, so you all don't do it again. Alright, so I'll put a p there. Okay, can okay, the next part would be to, okay, let's go back to how does it go. Okay, so all goes well, this should be your x, right? Your x should be equals to t minus e to the power of t, and differentiating your x, you should have dx dt should be equals to basically 1 minus e power t. Alright, your y is equals to 3 cosine square t minus 1. So dy dt, after differentiating, you should get eventually, okay, so power goes in front, you have 6 cosine power t, differentiating, you have negative sine t. Right, you should end up with a negative 3 sine 2t. Some of you actually forgot the negative sign, so your answer turned out that you lost the negative sign. I still gave you 1 mark error carry forward, but you will lose the accuracy mark later on. So dy dx will be equals to dy dt, alright, divided by dx dt. Alright, so if you have done this, right, if I at least see this, right, I'll actually give you 1 mark. Okay, so dy dx is basically 3 sine 2t, negative 3 sine 2t over 1 minus e power t. Some of you wrote 3 sine 2t, then e power t minus 1. I gave you the mark as well, okay, because it's equivalent. Alright, so I need to find the nature of the turning point. So, meaning, what do you need to do? Means your dy dx has to be equal to 0. So, if you equate dy dx equals to 0, what do you need to do next? Means you need to basically equate this to 0. And if you equate this to 0, well, it just means that your 3 sine 2t is equals to 0. And you're solving this, you're going to get t to be equal to 0, probably pi or 2 pi. Alright, that is where 2t is equal to 0, pi or 2 pi. So that is, okay, t equals to 0, pi over 2, or pi. Okay, that's where you need to observe the question carefully. The question actually told you that t has to be between 0 and pi. Right, this is from the question. Question actually told you this. So some of you actually went on to solve the t equals to 0, t equals to 2 pi, and find the nature of the stationary point. That is redundant. So you wasted a lot of time because you didn't read the question properly. So you always have to read the question carefully. So the only answer that we are dealing with is t equals to pi over 2. Okay? And t equals to pi over 2. So after you have t equals to pi over 2, this is the only one that you have. If you did this alone, out of the 3, and you got this correct, I'll still give you the mark. Okay, so t equals to pi over 2, what do you need to do next? You need to do the either first or second derivative. So some of you actually went on to so-called find d2y dx square. Alright, then you basically sub t equals to pi over 2. Okay, and then you conclude that it's a maximum. Conclude that it's a minimum. Alright, so if you do this correctly, okay, I will still give you the basically 1 mark for conducting the second derivative test, and of course A1 for concluding the minimum. Okay, that's provided you have done everything correctly, you have substituted the value here. So you cannot just write it's a positive or whatsoever. You have to really find the value. Okay, another alternative is to do the first derivative test. Okay, so if you did the first derivative test, okay, this is what we require. So we cannot just, most of you just write t, then pi over 2 minus pi over 2, pi over 2 plus. This one is not enough. Okay, so we have told you quite a few times that we cannot accept such inputs. You have to really sub in the value. Alright, so example, if you put pi over 2, you have to put in a value on the left that's less than pi over 2. For example, you put 1.6. On the right, you can put something maybe 1.5, for example. Alright, so you have to put in a proper value. You have to put in a proper value. Okay, so x, for example, if you put x here, x could be equal to negative 3.35303. If it's at pi over 2, it's negative 3.2396811. At 1.5 or negative 298168. Because basically you're using the inputting the value x equals to t minus e power t. Okay, so if you go back into the dy dx over here, you'll be negative, it'll be 0, and over here it will be positive. All right. So what does it mean? Okay, so you have to actually draw out a table. All right, and conclude that here, because the sign changes from negative positive. All right, so t from here you observe, right? Just observe carefully. Okay, right? T increases. Okay, as x decreases. Okay, so you can see that as x as decreases, going from the -2 to -3.3, you can see that the dy dx changes from a positive 0 to a negative, right? So the x coordinate is actually a minimum point. Alright, so it's actually a conclusion. So you can conclude that it is a minimum point. Okay, you should conclude that it's a minimum. So you need to give the correct conclusion. You can't just throw in write down the first derivative. You have to actually sub in values. Alright. Okay, last but not least, okay, I'm sure you can get that the x coordinate of the minimum point, alright, because they ask is pi over 2 minus e of pi over 2, because they ask for the exact coordinate. Okay, so you also cannot just say that by using GC, by using a graph, you say, or therefore you show that you draw the graph out and you show that it's a minimum point. You also cannot, because the question did say that you have to use differentiation. You have to use differentiation to conclude the nature of the turning point. Okay. Okay, next would be part 3. Okay, so we need to find the area of the integral. Okay, so most of you actually were able to draw the part where you have y equals to 2, and then you draw the graph, and then you found the two intercepts. Okay, that's very good. However, marks are not given for this. Okay, so when y equals to 2, okay, so what you need to do is you need to find the, okay, you know that eventually you are doing the integral from, so the thing is, how do you find the two bounds? Okay, so basically you need to equate, basically you need to find, okay, equate y equals to 2, equate this is the function which is y equals to 3 cosine square t minus 1. Okay, so basically after you equate the two of them, these two functions, you can find the two coordinates. All right, so if I equate 2 to 3 cosine square t minus 1, okay, solving this, I'll get cosine t to be plus minus 1, okay, with t equals to 0 or pi. Alright, so when t equals to 0, okay, using this, I obtain my x to be equals to -1, and when t equals to pi, x is equals to pi minus e power pi, okay, because we sub this into the function of x, where x is equals to t minus e power t. So what does this mean? It means that this point over here, the coordinate is none other than pi minus e power pi, as well as the value of y equals to 2, and over here the point would be -1 and comma 2. Okay, so once you have these 2 points, then to find the area bounded is actually quite easy. Yeah, so you just need to take basically the integral from, okay, -1, okay, to pi minus e power pi, right, and to 2 minus y dy dx. Okay, and then from here, how do we go about doing this? We need to convert this into parametric integration. So we need to do substitution. All right, so what we need to do next, you just need to take the y. Remember that y originally was our 3 cosine square t minus 1, right? This is our 3 cosine. Okay, then after that, what is minus 1? Minus 1, remember, when x is -1, t is actually equals to 0. Yeah, when x is equals to pi minus e over pi, what is your t? Your t is actually equals to pi. So we need to do the conversion slowly. And also, how do we change dx? So remember that just now, dx dt is equals to 1 minus e power t, right? So basically this is equals to, we just convert this 1 minus e power t dt. So actually quite a couple of you did forget this. So this portion here is a conversion of dx, and this conversion here is for y, and this is basically converted everything in terms of t. Okay, And next, how do we go about doing the next step? Okay, so next one, all okay, all you need to do is to go on and solve and simplify your integral before you go about doing the integration. Okay, so if you look at the what you have earlier on, this is the okay after doing all solutions. So remember that this is actually your dx, right? This is the dx. This is the 2 minus y, and these are the limits after changing it to in terms of t. Alright, so simplify this, you have 3 minus 3 cosine square, 1 minus e power t. Simplify it further, you take out the 3 here, you have 1 minus cosine square t. Then how do you go about doing this? Remember, you can actually change it to the to integrate a power of trigo, cosine square, right? To know that the skill here is that we need to do the using double angle. We need to convert this portion here. We need to use from here to here. We need to use double angle. So we need to use double angle to do the conversion of the trigo, okay, the integral. All right, simplify your trigo further, your integral further. All right, and simplify it further some more. Right, you can actually get 1 minus cos 2t, 1 minus e power t, and this is very simple. All right, then next part. Okay, next part. Okay, then you will end up with 3 over 2, 1 minus cos 2t minus e power t and e power t cosine 2t. Now this you just integrate, you get your t. This you integrate, you get sine 2t. E power t integrate, you get e power t. And how do you integrate this? Then this is actually the usage of part 1. So some of you actually will see this now. So this actually renders you 1 mark. That if you use the result from part 1. Using a double angle also gathers you another mark. Okay? And earlier on, while you find the correct integral, if you're able to find the correct integral, this also gives you another mark. Okay, so back to this portion. So solving this, all goes well, your answer should turn out to be negative 3 over 2, b equals to negative 6 over 5, and c equals to 6 over 5. Okay, unfortunately, this question is not very well done. So even a lot of you actually I think not more than 5 in the cohort were able to get the correct answer. Okay,